Welcome to Question Bank Hub. Welder Red Seal Exam Practice. 125 questions, answered and explained. Based on the 2021 Red Seal Occupational Standard. This exam covers 125 questions across 4 major work activities. Questions test knowledge recall, procedural application, and critical thinking. Take your time with each question, and let's begin. Question 1. What is the primary purpose of regularly inspecting hand tools before use? A. To identify damage that could cause injury or poor quality work. B. To ensure tools are clean and presentable. C. To verify the tool manufacturer's warranty is valid. D. To determine if tools need to be replaced for newer models. The correct answer is A. To identify damage that could cause injury or poor quality work. Inspecting hand tools before use is essential to identify any damage, wear, or defects that could cause injury to the user or result in poor quality work. Damaged tools such as mushroom chisel heads, cracked handles, or worn wrenches can slip or break during use, creating serious safety hazards. This inspection is a fundamental safety practice in the welding trade. Question 2. What is the correct procedure for maintaining a stationary grinder? A. Replace the grinding wheel only when it shows visible wear or very heavy damage. B. Check wheel condition, tool rest gap, and guard position. C. Oil the motor bearings weekly regardless of the machine use or operating hours. D. Clean the machine thoroughly at the end of each month using proper solvents. The correct answer is B. Check wheel condition, tool rest gap, and guard position. Proper maintenance of a stationary grinder includes checking the grinding wheel for cracks or damage, adjusting the tool rest to maintain a gap of 3 mm, 1/8 inch, or less from the wheel, and verifying the guard is properly positioned. These checks should be performed before each use to prevent wheel breakage, which can cause serious injury. The tool rest gap prevents work from being pulled into the wheel. Question 3. When maintaining oxy-fuel cutting equipment, what should be checked on the regulators? A. Only the color coding matches the gas cylinder labels and markings. B. The serial numbers are visible, legible, and match documentation records. C. Diaphragm integrity, gauge accuracy, and connection fittings for leaks. D. The regulator brand matches the torch brand for warranty coverage. The correct answer is C. Diaphragm integrity, gauge accuracy, and connection fittings for leaks. When maintaining oxy-fuel regulators, it is essential to check the diaphragm for damage or deterioration, verify gauge accuracy against known standards, and inspect all connection fittings for leaks using appropriate leak detection solution. Faulty regulators can cause dangerous pressure fluctuations, inaccurate gas flow readings, or gas leaks that create fire and explosion hazards. Question 4. What is a critical maintenance item for welding cables? A. Ensuring the cable color matches the welding machine. B. Verifying the cable length is exactly as specified by the manufacturer. C. Cleaning the cable exterior with solvent after each use. D. Checking for cuts, cracks, or exposed conductors in the insulation. The correct answer is D. Checking for cuts, cracks, or exposed conductors in the insulation. Inspecting welding cables for cuts, cracks, or exposed conductors is critical for safety. Damaged insulation can cause electrical shock to the welder or create short circuits that damage equipment. Exposed conductors may also cause arc flash incidents. Cables should be inspected regularly and repaired or replaced immediately if damage is found. Question 5. What must be done before using a scaffold for welding work? A. Inspect for damage, ensure proper assembly, and verify it is secured. B. Paint the scaffold in a bright color for visibility. C. Remove all scaffold wheels to prevent movement. D. Apply heat-resistant tape to all scaffold connection points before use. The correct answer is A. Inspect for damage, ensure proper assembly, and verify it is secured. Before using a scaffold, welders must inspect it for damage such as bent frames or missing components, ensure it has been properly assembled according to manufacturer specifications, and verify it is secured to prevent movement during work. Scaffolds must also be set up on stable, level ground. These precautions prevent falls, which are a leading cause of workplace injuries in construction and industrial settings. Question 6. What is the minimum overlap required when extending extension ladders? A. At least one rung overlap regardless of ladder length. B. At least 3 rungs overlap for ladders up to 11 meters, 36 feet. C. No overlap is required if the ladder is properly tied off. D. Overlap depends on the worker's preference and experience. The correct answer is B. At least 3 rungs overlap for ladders up to 11 meters, 36 feet. Extension ladders require a minimum of 3 rungs overlap for ladders up to 11 meters, 36 feet, and 4 rungs for longer ladders. This overlap ensures the ladder maintains structural integrity and can safely support the worker's weight. Insufficient overlap can cause the ladder sections to separate or collapse during use. Question 7. What is the first step when preparing to rig a load for lifting? A. Attach the slings to the load immediately without delay. B. Signal the crane operator to begin the lifting operation. C. Determine the weight and center of gravity of the load. D. Select the smallest slings available to save setup time. The correct answer is C. Determine the weight and center of gravity of the load. The first step in rigging is to determine the weight and center of gravity of the load. This information is essential for selecting appropriate rigging equipment with adequate capacity and for positioning attachment points to ensure the load will be balanced during the lift. Lifting an unbalanced load can cause it to shift, tip, or fall, creating serious hazards. Question 8. A welder notices that a wire rope sling has several broken wires near the eye. What should be done? A. Use the sling but reduce the load capacity by 25%. B. Wrap tape around the damaged area and continue using it. C. Use the sling only for light loads until a replacement arrives. D. Remove the sling from service and tag it for disposal or repair. The correct answer is D. Remove the sling from service and tag it for disposal or repair. A wire rope sling with broken wires must be immediately removed from service and tagged for disposal or professional repair. Broken wires indicate the sling has been damaged or has reached the end of its service life. Continuing to use damaged rigging equipment risks catastrophic failure under load, which can cause serious injury or death. Industry standards specify maximum allowable broken wire counts. Question 9. What factor reduces the working load limit of a sling when used at an angle? A. The sling angle from vertical. B. The temperature of the environment. C. The total length of the sling between attachment points. D. The weight of the rigging hardware attached to the sling. The correct answer is A. The sling angle from vertical. The sling angle from vertical significantly affects its working load limit. As the sling angle decreases from 90 degrees, vertical, more of the load force creates horizontal stress on the sling rather than being supported vertically. At a 45-degree angle, the load capacity is reduced to approximately 70% of the vertical rating. At 30 degrees, it drops to about 50%. Riggers must calculate these reductions when planning lifts. Question 10. When conducting a hazard assessment before welding, what should be identified first? A. The fastest route to complete the job with minimum delay and best efficiency. B. Potential ignition sources and combustibles in area. C. The type of welding rod or filler metal specified for the job. D. The production schedule and estimated completion time for the project. The correct answer is B. Potential ignition sources and combustibles in area. When conducting a hazard assessment, identifying potential ignition sources and combustible materials is the first priority because welding produces sparks, molten metal, and intense heat that can ignite fires. The assessment should identify flammable liquids, gases, dust, paper, wood, and other combustibles within the welding area and spark travel zone. These hazards must be controlled before welding begins. Question 11. What is the correct procedure for setting up fire watch during welding operations? A. Fire watch is only needed if the supervisor specifically requests it for the job today. B. One fire extinguisher somewhere in the building is sufficient for the fire protection. C. Position trained personnel with fire extinguishing equipment who monitor during and for 30 minutes after welding. D. Fire watch procedures only apply to outdoor welding operations and field work areas. The correct answer is C. Position trained personnel with fire extinguishing equipment who monitor during and for 30 minutes after welding. Fire watch requires trained personnel positioned with appropriate fire extinguishing equipment to monitor the welding area during operations and for a minimum of 30 minutes after welding stops. This post-welding monitoring period is critical because sparks and hot metal can smolder in hidden areas before igniting into flames. The fire watch person must know how to use the extinguishing equipment and how to sound the alarm if needed. Question 12. What is the minimum ventilation requirement when welding in a confined space? A. No ventilation is required if the welder wears a proper respirator for protection. B. Natural ventilation through an open door or window is always sufficient overall. C. Ventilation is only needed when welding galvanized or coated materials in shop. D. Continuous mechanical ventilation providing adequate air. The correct answer is D. Continuous mechanical ventilation providing adequate air. Confined space welding requires continuous mechanical ventilation providing adequate air changes per hour to remove welding fumes and ensure sufficient oxygen levels. Natural ventilation is typically insufficient due to limited air movement in confined spaces. The ventilation rate must be calculated based on the space volume, welding process, and base metal being welded. Atmospheric monitoring is also required. Question 13. What shade number is typically required for SMAW welding at 100 to 150 amperes? A. Shade 10 to 11. B. Shade 5 to 7. C. Shade 8 to 9. D. Shade 14. The correct answer is A. Shade 10 to 11. For SMAW welding at 100 to 150 amperes, shade 10 to 11 filter lenses are typically required to protect the welder's eyes from harmful ultraviolet and infrared radiation. The appropriate shade number increases with higher amperage settings. Using insufficient shade protection can cause arc eye, photokeratitis, and long-term eye damage. Welders should always verify the appropriate shade for their specific amperage and process. Question 14. What personal protective equipment is required when grinding a weld? A. Only safety glasses are needed for basic grinding protection. B. Face shield, safety glasses, hearing protection, and gloves. C. A welding helmet is sufficient for all grinding operations. D. No additional personal protective equipment is required for grinding after welding. The correct answer is B. Face shield, safety glasses, hearing protection, and gloves. Grinding requires multiple forms of personal protective equipment: a face shield for protection against flying particles, safety glasses worn underneath the face shield for backup eye protection, hearing protection due to the high noise levels produced by grinding, and leather gloves to protect hands from hot metal and abrasion. The combination of hazards from grinding requires comprehensive protection. Question 15. What information does a welding procedure specification, provide? A. Only the welder's name, certification number, and employer information. B. The cost estimate for the welding project and material expenses. C. Joint design, base metal, filler metal, preheat, and technique details. D. The schedule for when welding should be performed on the project. The correct answer is C. Joint design, base metal, filler metal, preheat, and technique details. A welding procedure specification, provides detailed information about all essential variables for producing an acceptable weld. This includes joint design, base metal specifications, filler metal type and size, preheat and interpass temperatures, welding position, electrical parameters, and technique requirements. Following the welding procedure specification ensures consistent weld quality and compliance with applicable codes and standards. Question 16. When reading a welding symbol, where is the information for the other side of the joint, opposite the arrow, shown? A. Below the reference line. B. Inside the tail of the symbol. C. To the left of the reference line. D. Above the reference line. The correct answer is D. Above the reference line. In standard welding symbols, information for the other side of the joint, opposite to where the arrow points, is placed above the reference line. Information for the arrow side of the joint is placed below the reference line. This convention allows welders to quickly identify which side of the joint requires specific preparation or welding based on the symbol orientation. Question 17. What should be done when planning a multi-pass weld on thick plate? A. Plan the sequence of passes to control distortion and ensure fusion. B. Use the highest amperage possible to complete the weld quickly. C. Apply all passes from the same direction without any pause. D. Skip intermediate cleaning between passes to save work time. The correct answer is A. Plan the sequence of passes to control distortion and ensure fusion. When planning multi-pass welds on thick plate, the sequence of passes must be carefully planned to control distortion and ensure proper fusion between passes. This includes determining bead placement, backstep or other sequencing techniques, and allowing for thermal expansion. Proper planning minimizes residual stress, reduces distortion, and ensures the weld meets quality requirements. Question 18. What is the purpose of organizing materials before starting a welding job? A. To make the work area look neat and tidy for inspections and site visits from management. B. To ensure materials are available and identified to prevent delays. C. To create more space for personal items and tool storage requirements throughout the shop. D. To allow the supervisor to count inventory and track material usage and consumption daily. The correct answer is B. To ensure materials are available and identified to prevent delays. Organizing materials before welding ensures all required materials are available and properly identified, preventing costly delays from missing items and errors from using incorrect materials. This includes verifying base metal specifications, confirming filler metal type and condition, checking consumable inventory, and ensuring all fixtures and tooling are ready. Proper organization improves efficiency and weld quality. Question 19. A welder is assigned a job requiring welding on high-strength steel, but the welding procedure specification calls for 150 C minimum preheat. The shop has no heating equipment available. What should the welder do? A. Proceed without preheat since the steel appears to be in good condition. B. Use a rosebud torch held in the other hand while actively welding. C. Stop work and notify the supervisor that required equipment is unavailable. D. Substitute a different type of steel that does not require any preheat. The correct answer is C. Stop work and notify the supervisor that required equipment is unavailable. The welder must stop work and notify the supervisor that required equipment is not available. High-strength steel requires preheat to prevent hydrogen-induced cracking. Welding without proper preheat could result in delayed cracking that compromises structural integrity. The welding procedure specification requirements are mandatory and cannot be bypassed without proper engineering approval. Question 20. What is included in a visual inspection of a completed weld? A. Only checking if the weld is the correct color appearance and looks acceptable. B. Measuring only the weld length and comparing dimensions to the engineering drawings. C. Checking only the bottom side of the weld for burn-through defects and issues. D. Examining for surface defects, proper size, and profile. The correct answer is D. Examining for surface defects, proper size, and profile. Visual inspection of a completed weld includes examining for surface defects such as cracks, porosity, undercut, and incomplete fusion, verifying proper weld size using gauges, checking the weld profile for acceptable reinforcement or concavity, and ensuring overall conformance to the drawing and welding procedure specifications. Visual inspection is the first and most common quality control method for welds. Question 21. Why is controlling interpass temperature important during welding? A. It helps maintain proper metallurgical properties and prevents cracking or loss of strength. B. It only affects how fast the welder can complete the welding job on the project. C. It is only important for cosmetic appearance of the finished weld on assemblies. D. It has no significant effect on the final weld quality outcome or joint strength. The correct answer is A. It helps maintain proper metallurgical properties and prevents cracking or loss of strength. Controlling interpass temperature is essential for maintaining proper metallurgical properties in the heat-affected zone and weld metal. Excessive interpass temperature can cause grain growth, reduce mechanical properties, and increase distortion. Insufficient temperature, allowing the weld to cool too much between passes, can lead to hydrogen cracking in certain steels. The welding procedure specification specifies maximum interpass temperature limits that must be monitored. Question 22. How should low hydrogen electrodes be stored after opening the package? A. In any dry location at room temperature with the package sealed. B. In a heated rod oven at the temperature specified by manufacturer. C. In a plastic bag in the refrigerator to maintain low moisture. D. In the original packaging stored on the shop floor in dry area. The correct answer is B. In a heated rod oven at the temperature specified by manufacturer. Low hydrogen electrodes must be stored in a heated rod oven at the temperature specified by the manufacturer, typically between 120 to 150 C, 250 to 300 F, after the package is opened. These electrodes have low moisture flux coatings that readily absorb atmospheric moisture. If the electrodes pick up moisture, the hydrogen released during welding can cause cracking in the weld or heat-affected zone. Question 23. A welder needs to join 6 mm stainless steel sheet in the vertical position with good appearance on both sides. Which process would be most suitable? A. Submerged arc welding, SAW. B. Flux cord arc welding with self-shielded wire. C. Gas tungsten arc welding, GTAW. D. Oxyfuel welding. The correct answer is C. Gas tungsten arc welding, GTAW. GTAW, TIG welding, is most suitable for this application because it provides excellent control for vertical position welding, produces clean welds with no slag or spatter that would affect appearance, and allows for precise heat input control needed for thin stainless steel. SAW is not practical for vertical position, FCAW produces more spatter, and oxyfuel does not provide adequate heat concentration for efficient stainless steel welding. Question 24. What is the correct method for removing weld spatter from a finished product? A. Using a cold chisel and heavy hammer to break spatter free from the surface. B. Leaving all spatter in place as it protects the metal surface from corrosion. C. Burning off spatter with an oxyfuel torch set to neutral flame for removal. D. Using chipping hammer, wire brush, or grinding while taking care to avoid damaging the base metal. The correct answer is D. Using chipping hammer, wire brush, or grinding while taking care to avoid damaging the base metal. Weld spatter should be removed using appropriate tools such as a chipping hammer, wire brush, or light grinding, while being careful to avoid damaging the base metal surface. The method selected depends on the material and finish requirements. Spatter must be removed as it can interfere with coating adhesion, cause assembly problems, and detract from appearance. Care must be taken not to create gouges or scratches in the base material. Question 25. What is the primary purpose of developing a template before cutting material? A. To ensure accurate and repeatable part shapes while minimizing waste. B. To make the finished product look more professional and uniform. C. To satisfy quality control documentation and inspection requirements. D. To demonstrate the welder's drafting skills and attention to detail. The correct answer is A. To ensure accurate and repeatable part shapes while minimizing waste. Templates are developed to ensure accurate and repeatable part shapes while minimizing material waste. A well-made template allows multiple identical parts to be marked and cut efficiently without remeasuring each time. Templates also reduce the chance of errors by providing a physical pattern that can be verified before cutting begins. Question 26. When developing a template for a pipe saddle cut, what information must be calculated? A. Only the diameter of the pipe being cut for the saddle joint. B. The intersecting pipe diameters, angle of intersection, and profile points. C. The weight of the finished assembly including all fittings used. D. The color coding for the pipe material and manufacturer identification. The correct answer is B. The intersecting pipe diameters, angle of intersection, and profile points. Developing a template for a pipe saddle cut requires calculating the intersecting pipe diameters, the angle of intersection, and the resulting profile points that define the cut line. This geometric calculation determines the compound curve that must be cut to allow one pipe to fit precisely against another. Templates may be developed using mathematical calculations, layout tools, or specialized software. Question 27. What type of measuring tool is most appropriate for transferring dimensions from a drawing to sheet metal? A. A wooden folding ruler for general use. B. A cloth tape measure for flexible work. C. A steel tape or combination square. D. A laser distance meter for long spans. The correct answer is C. A steel tape or combination square. A steel tape or combination square is most appropriate for transferring dimensions to sheet metal because these tools provide accurate measurements and can be used to scribe lines directly on the metal surface. Steel measuring tools maintain their accuracy over time and are not affected by temperature changes like some other materials. The combination square also allows for marking 90-degree and 45-degree angles. Question 28. What is the correct procedure for establishing a baseline on material for layout? A. Use any edge of the material as the baseline reference point. B. Start measuring from the center of the material outward. C. Use the lightest colored edge as the baseline for visibility. D. Select a straight, verified edge or establish a reference line. The correct answer is D. Select a straight, verified edge or establish a reference line. Establishing a baseline requires selecting a straight, verified edge or using a straight edge to establish a reference line. All other measurements are then taken from this baseline. If the material edge is not straight or has been damaged, a new reference line must be scribed parallel to the edge. An inaccurate baseline will cause cumulative errors in the layout. Question 29. When laying out a hole pattern on plate, what should be done to ensure accuracy? A. Use center punch marks at all intersection points. B. Estimate the locations visually for speed to save time on the project. C. Drill the first hole and measure from it for the rest of the holes. D. Use only one measurement from each edge of the material plate. The correct answer is A. Use center punch marks at all intersection points. Using center punch marks at all intersection points ensures accuracy when drilling hole patterns. The punch marks provide a positive locating point that prevents the drill from wandering when starting the hole. The layout should be verified by measuring between punch marks before drilling begins. This method produces consistent hole spacing and prevents costly rework. Question 30. What is the purpose of using layout fluid, dicom, on metal surfaces? A. To protect the metal from corrosion during storage. B. To provide contrast so scribed lines are more visible. C. To lubricate the metal for easier cutting. D. To indicate areas that have already been welded. The correct answer is B. To provide contrast so scribed lines are more visible. Layout fluid, such as dicom, is applied to metal surfaces to provide contrast that makes scribed lines more visible. The fluid dries to a thin, opaque coating that shows scratches clearly. When a scriber marks through the coating, the bright metal underneath becomes visible against the dark background. This makes it much easier to follow layout lines during cutting and forming operations. Question 31. A welder needs to make 50 identical bracket plates from 6 mm steel. What is the most efficient approach? A. Measure and mark each plate individually from the drawing provided. B. Cut one plate by eye and use it as a reference for the others. C. Create a durable template and use it to mark all plates before cutting. D. Cut all plates oversize and grind them to the final required dimensions. The correct answer is C. Create a durable template and use it to mark all plates before cutting. Creating a durable template for 50 identical parts is the most efficient approach. The template can be verified once for accuracy and then used repeatedly to mark all plates before cutting. This eliminates the cumulative errors that can occur with repeated measurements and significantly reduces layout time. For production quantities, investing time in an accurate template pays dividends in quality and efficiency. Question 32. When transferring dimensions from a drawing that shows a 2:1 scale, what must be done? A. Double all the measurements from the drawing. B. Use the dimensions directly without modification. C. Add 50% to each dimension. D. Divide all dimensions by 2 to get actual size. The correct answer is D. Divide all dimensions by 2 to get actual size. When a drawing is at 2:1 scale, the drawn dimensions are twice the actual size, so all dimensions must be divided by 2 to get the actual size. It is essential to note the scale indicated on the drawing and apply the correct conversion. Many drawings include both scaled dimensions and actual dimensions in the title block to prevent errors. Question 33. What tool is used to scribe arcs and circles on metal during layout? A. Dividers or Dremel points for arcs. B. A protractor for angle measurement. C. A speed square for marking angles. D. A bubble level for horizontal check. The correct answer is A. Dividers or Dremel points for arcs. Dividers or Dremel points are used to scribe arcs and circles on metal during layout. Dividers consist of two pointed legs that can be adjusted to any radius. For larger circles, Dremel points, beam compass, are used with an adjustable beam. Both tools allow accurate circular layouts when a center point is established. Question 34. How should allowances for weld shrinkage be incorporated into layout? A. Weld shrinkage does not need to be considered during the layout phase at all. B. Add extra material to compensate for shrinkage based on size. C. Subtract material from the layout dimensions to account for the expansion effect. D. Weld only on one side to eliminate shrinkage effects on the assembly structure. The correct answer is B. Add extra material to compensate for shrinkage based on size. Layout dimensions should include allowances for weld shrinkage by adding extra material based on the weld size, material thickness, and number of welds. Shrinkage occurs as the weld cools and contracts, which can pull the assembly out of dimension. The amount of shrinkage allowance depends on the welding process, joint design, and restraint conditions. Question 35. What is the purpose of beveling the edge of a plate before welding? A. To make the plate lighter and easier to handle during fabrication work. B. To improve the appearance of the finished product for visual inspection. C. To allow full penetration of the weld into the joint thickness. D. To reduce the amount of filler metal needed for the weld completion. The correct answer is C. To allow full penetration of the weld into the joint thickness. Beveling the edge of a plate creates a groove that allows full penetration of the weld into the joint. This is necessary when the plate thickness exceeds what can be fully penetrated with a square butt joint. The bevel angle and root face dimensions are specified in the welding procedure to ensure adequate fusion throughout the joint thickness. Question 36. What is the correct method for removing mill scale from steel before welding? A. Leave the mill scale in place as it protects the steel from corrosion damage. B. Apply paint over the mill scale before the welding operation starts on joint. C. Weld through the mill scale using higher amperage for better fusion at joint. D. Remove mill scale by grinding, brushing, or blasting. The correct answer is D. Remove mill scale by grinding, brushing, or blasting. Mill scale must be removed from steel before welding by grinding, wire brushing, sandblasting, or other mechanical means. Mill scale is a layer of iron oxide that forms during hot rolling and can cause weld defects including porosity and lack of fusion. The base metal surface should be clean and bright in the weld area and any adjacent areas that will be affected by heat. Question 37. What contaminant must be removed from aluminum before welding? A. The oxide layer that forms on the surface of the aluminum. B. The anodized color coating only from the material surface preparation process. C. Any moisture that may be present on the aluminum surface before welding begins. D. Surface dust and dirt only that can be removed with simple wiping techniques. The correct answer is A. The oxide layer that forms on the surface of the aluminum. The aluminum oxide layer must be removed before welding because it has a much higher melting point, approximately 2050 C, than the aluminum base metal, 660 C. If the oxide is not removed, it will remain solid while the aluminum melts, causing inclusions in the weld. The oxide layer is removed by stainless steel wire brushing or chemical cleaning immediately before welding. Question 38. What is the purpose of using tack welds when fitting components? A. To complete the welding process faster and save time on the project schedule. B. To hold parts in alignment during final welding. C. To strengthen weak areas of the joint that may be prone to failure. D. To satisfy inspection requirements and quality control documentation needs. The correct answer is B. To hold parts in alignment during final welding. Tack welds hold parts in alignment during final welding. They are small welds placed at intervals along the joint to maintain the gap, alignment, and fit up as the assembly expands and contracts during welding. Tack welds must be properly sized and placed, and may need to be removed or incorporated into the final weld depending on the application. Question 39. When fitting a butt joint, what determines the proper root opening? A. The welder's personal preference for gap size. B. The thickness of the electrode coating material. C. The welding procedure and plate thickness. D. The ambient temperature in the fabrication shop. The correct answer is C. The welding procedure and plate thickness. The proper root opening for a butt joint is determined by the welding procedure specification, and the plate thickness. The root opening provides space for the weld metal to penetrate to the back of the joint. Too small an opening results in lack of penetration, too large an opening wastes filler metal and increases distortion. The welding procedure specification specifies the acceptable range for root opening. Question 40. What is the primary function of a backing bar in groove welding? A. To increase the travel speed during welding operations. B. To reduce the amount of shielding gas needed for the joint. C. To eliminate the need for a second pass on the joint. D. To support the molten weld pool and control root bead shape. The correct answer is D. To support the molten weld pool and control root bead shape. A backing bar supports the molten weld pool and controls the root bead shape during groove welding. It prevents the molten metal from falling through the joint and produces a smooth, consistent root surface. Backing bars may be temporary, removed after welding, or permanent, left in place. The type used depends on the application and specification requirements. Question 41. When assembling a box structure, what sequence helps control distortion? A. Weld opposite sides alternately rather than one side. B. Complete all welds on one side before starting the next side of the box. C. Weld from the center outward on all sides simultaneously for even heating. D. Apply heat to only one corner at a time to control the heat input level. The correct answer is A. Weld opposite sides alternately rather than one side. Welding opposite sides alternately helps control distortion by balancing the heat input and resulting shrinkage stresses. This technique, sometimes called backstep or balanced welding, allows one side to cool while the opposite side is welded. If all welds are completed on one side first, the unbalanced shrinkage will cause the structure to distort toward the welded side. Question 42. A welder is fitting two plates for a butt weld but notices the root opening varies from 2 mm at one end to 5 mm at the other. What should be done? A. Proceed with welding and fill the larger gap with more filler metal. B. Refit the joint to achieve consistent root opening before welding. C. Weld only the end with the smaller gap. D. Use backing to fill the larger gap. The correct answer is B. Refit the joint to achieve consistent root opening before welding. The joint should be refit to achieve consistent root opening before welding. Varying root opening makes it difficult to maintain consistent penetration along the joint and increases the risk of defects. At the narrow end, there may be lack of penetration. At the wide end, burn-through may occur. Proper fit-up is essential for producing a quality weld. Question 43. What is the correct procedure for forming a bend in plate steel using heat? A. Apply maximum heat to one small spot and then bend quickly. B. Heat the entire plate evenly before bending to temperature. C. Apply linear heat along the bend line to the specified temperature before bending. D. Cool the plate with water immediately after heating it. The correct answer is C. Apply linear heat along the bend line to the specified temperature before bending. Forming a bend in plate steel using heat requires applying linear heat along the bend line to a specified temperature appropriate for the material, then bending. The heated zone becomes plastic and allows the material to be bent without cracking. The temperature must be controlled. Too low and the material will not bend easily, too high and the metallurgical properties may be damaged. Question 44. What is the purpose of using clamps and fixtures during assembly? A. To make the assembly look more professional and presentable. B. To speed up the welding process only without other benefits. C. To satisfy documentation requirements for quality control. D. To maintain accurate alignment and positioning during welding. The correct answer is D. To maintain accurate alignment and positioning during welding. Clamps and fixtures are used to maintain accurate alignment and positioning during welding. They hold components in the correct position relative to each other and resist the forces created by weld shrinkage. Proper fixturing reduces the amount of tack welding needed and helps produce assemblies that meet dimensional requirements without excessive straightening after welding. Question 45. When fitting a T-joint, how should the perpendicularity be verified? A. Using a square against both members at multiple points along the joint. B. Estimating by eye from a distance only. C. Measuring the leg lengths of the fillet weld. D. Checking only at the ends of the joint line. The correct answer is A. Using a square against both members at multiple points along the joint. Perpendicularity of a T-joint should be verified using a square placed against both members at multiple points along the joint. Checking at multiple locations ensures that the perpendicular relationship is maintained along the entire length, not just at the ends. Any variation from 90 degrees will affect the stress distribution and may cause the assembly to be out of specification. Question 46. What safety precaution must be taken when grinding bevels on stainless steel? A. Use a grinding wheel designed for aluminum materials and non-ferrous metals. B. Use a dedicated wheel not used on carbon steel. C. Apply water cooling to the grinding wheel during the grinding operation. D. Grind only in short bursts to prevent heating and discoloration damage. The correct answer is B. Use a dedicated wheel not used on carbon steel. When grinding stainless steel, a dedicated grinding wheel that has not been used on carbon steel must be used. Carbon steel particles embedded in the wheel can be transferred to the stainless steel surface, causing contamination that leads to corrosion. Many shops maintain separate grinding equipment for stainless steel and mark it clearly to prevent cross-contamination. Question 47. An assembly requires welding a thin, 3 mm, plate to a thick, 25 mm, plate. What consideration is important during fit-up? A. Only the thick plate requires edge preparation for proper joint access and fusion. B. The plates can be fitted without any special consideration for thickness at all. C. Position the thin plate to minimize direct heat and allow heat dissipation into the thick plate. D. The thick plate should be preheated to match the thin plate temperature level. The correct answer is C. Position the thin plate to minimize direct heat and allow heat dissipation into the thick plate. When joining plates of different thicknesses, fit-up should position the thin plate to minimize heat concentration and allow heat dissipation into the thick plate. The thick plate acts as a heat sink while the thin plate heats quickly. Welding technique and joint design must account for this difference to avoid burn-through on the thin plate while achieving adequate fusion on the thick plate. Question 48. What is the purpose of presetting or pre-bending components before welding? A. To reduce the need for edge preparation work. B. To increase the welding speed significantly. C. To eliminate the need for tack welds entirely. D. To compensate for distortion during welding. The correct answer is D. To compensate for distortion during welding. Presetting or pre-bending components before welding compensates for the distortion that will occur during welding. The parts are set in a position opposite to the expected distortion direction. As the weld shrinks, it pulls the assembly back toward the correct position. The amount of preset depends on the weld size, material thickness, and restraint conditions. Question 49. When assembling pipe to a flange, what must be verified before tacking? A. The paint color of the flange matches the pipe color. B. The pipe manufacturer matches the flange manufacturer. C. The weld filler metal is already placed in the joint. D. The pipe is centered in bore and perpendicular to face. The correct answer is D. The pipe is centered in bore and perpendicular to face. Before tacking pipe to a flange, the pipe must be verified to be centered in the flange bore and perpendicular to the flange face. Misalignment will cause the mating flange faces to not seat properly, leading to leaks or uneven bolt loads. Proper alignment is checked using squares and measuring the gap between the pipe and flange bore at multiple points around the circumference. Question 50. What factor determines the selection of a cutting wheel for an angle grinder? A. The material being cut, wheel speed, and RPM. B. The color of the wheel and its appearance characteristics for identification. C. The preference of the tool room attendant or supervisor for the selection. D. The cost of the wheel and budget constraints for the job requirements. The correct answer is A. The material being cut, wheel speed, and RPM. Cutting wheel selection depends on the material being cut, different wheels for steel, stainless, aluminum, the wheel's rated speed, and the grinder's RPM. Using a wheel rated lower than the grinder's speed can cause catastrophic wheel failure. Different materials require different abrasive compositions, for example, aluminum oxide for steel and silicon carbide for non-ferrous metals. Question 51. What is the correct procedure for starting a cut on a band saw? A. Force the material into the blade at maximum feed rate for fast cutting speed. B. Allow blade to reach full speed before slowly feeding. C. Start the saw with the material already pressed against the blade for stability. D. Use maximum cutting fluid to lubricate the blade during startup and operation. The correct answer is B. Allow blade to reach full speed before slowly feeding. The correct procedure is to allow the band saw blade to reach full speed before slowly feeding the material into the blade. Starting the saw with material against the blade can cause blade breakage or strip teeth. The initial feed should be slow until the blade is fully engaged in the cut, then the feed rate can be adjusted based on material type and blade condition. Question 52. What is the maximum thickness of material that can typically be cut with a foot-operated iron worker? A. 3 mm, 1/8 inch, for all standard steel materials. B. 6 mm, 1/4 inch, for all standard steel materials. C. Depends on machine rating and material type being cut. D. 50 mm, 2 inches, regardless of material type used. The correct answer is C. Depends on machine rating and material type being cut. The maximum thickness that can be cut with an iron worker depends on the specific machine rating and the material type being cut. Iron workers are rated in tons and the capacity charts indicate maximum thickness for various materials, mild steel, stainless steel, etc. Exceeding the rated capacity can damage the machine and create safety hazards. Question 53. When using a hacksaw to cut metal tubing, how should the blade be positioned? A. With the teeth pointing backward toward the handle. B. With no specific orientation as it cuts both ways. C. At a 45-degree angle to the work. D. With the teeth pointing forward, away from the handle. The correct answer is D. With the teeth pointing forward, away from the handle. Hacksaw blades should be installed with the teeth pointing forward, away from the handle. The hacksaw cuts on the push stroke, and proper blade orientation ensures efficient cutting. The blade should be tensioned according to manufacturer specifications. Too loose causes blade wander, while too tight may cause breakage. Question 54. What safety check must be performed before using a portable cutoff saw? A. Verify guard is in place and blade is not cracked. B. Check that the extension cord is the correct color for safety identification. C. Ensure the material is painted before cutting to protect against corrosion. D. Confirm the cutoff saw has been used within the past month for reliability. The correct answer is A. Verify guard is in place and blade is not cracked. Before using a portable cutoff saw, the guard must be verified as in place and properly adjusted, and the blade must be inspected for cracks or damage. A cracked abrasive wheel can disintegrate at high speed, causing serious injury. The guard protects the operator from sparks and debris. All safety features must be functional before operation. Question 55. What type of grinding wheel is typically used for sharpening tungsten electrodes? A. Aluminum oxide wheel rated for ferrous metals and general grinding purposes. B. Silicon carbide or diamond wheel for tungsten. C. Any available grinding wheel in the shop will work for the tungsten sharpening. D. Rubber bonded wheel for polishing applications and final finishing operations. The correct answer is B. Silicon carbide or diamond wheel for tungsten. Tungsten electrodes should be sharpened on a silicon carbide or diamond wheel that is dedicated for tungsten only. Using a wheel contaminated with other metals can contaminate the tungsten electrode, leading to arc instability and weld contamination. The dedicated wheel ensures clean, consistent electrode tips without cross-contamination. Question 56. What type of gas provides the highest flame temperature when combined with oxygen for cutting? A. Propane gas. B. Acetylene. C. Natural gas. D. Propylene. The correct answer is B. Acetylene. Acetylene provides the highest flame temperature, approximately 3,480 C, when combined with oxygen. This makes it the preferred fuel gas for cutting thick materials and when fast piercing is required. Other fuel gases like propane and natural gas have lower flame temperatures but may be preferred for specific applications due to cost, availability, or safety considerations. Question 57. What is the correct sequence for setting up oxy-fuel cutting equipment? A. Light the torch first, then connect the hoses and regulators to the cylinders. B. Set both regulators to maximum pressure before opening the cylinder valves. C. Secure cylinders, install regulators, connect hoses, open valves, adjust pressures. D. Open the oxygen cylinder fully then the fuel gas cylinder fully at the same time. The correct answer is C. Secure cylinders, install regulators, connect hoses, open valves, adjust pressures. The correct setup sequence is: secure cylinders in upright position, install regulators with adjusting screws released, valves closed, connect hoses with correct color coding, slowly open cylinder valves, oxygen fully, fuel gas 1 to 1.5 turns, then adjust working pressures. This sequence prevents equipment damage and ensures safe operation. Question 58. Why must oxygen equipment be kept free of oil and grease? A. Oil causes the oxygen to smell unpleasant during use. B. Oil will clog the regulator passages and restrict flow. C. Oil reduces the purity of the oxygen being delivered. D. Oil can ignite spontaneously with high-pressure oxygen. The correct answer is D. Oil can ignite spontaneously with high-pressure oxygen. Oil and grease can ignite spontaneously when exposed to high-pressure oxygen, causing fires or explosions. This is why oxygen equipment must never be lubricated with petroleum-based products and must be kept scrupulously clean. Hands must be free of oil when handling oxygen equipment, and only approved lubricants may be used on oxygen regulators. Question 59. How is the correct cutting tip size selected for oxyfuel cutting? A. Based on material thickness per manufacturer chart. B. By using the smallest available tip for all thicknesses regardless of material. C. By selecting the tip with the cleanest orifice available in the shop inventory. D. Based on the color coding of the tip and manufacturer identification marks. The correct answer is A. Based on material thickness per manufacturer chart. The correct cutting tip size is selected based on material thickness according to the manufacturer's chart. Each tip size is designed for a specific thickness range and requires corresponding oxygen and fuel gas pressures. Using too small a tip results in slow cutting and poor edge quality. Too large a tip wastes gas and may overheat thin materials. Question 60. What is the correct procedure for piercing a hole in plate with an oxy-fuel torch? A. Immediately apply cutting oxygen when the torch is lit up. B. Preheat until molten, then apply oxygen while tilting. C. Cut from the edge of the plate to the desired location. D. Use only the fuel gas flame to melt through the plate. The correct answer is B. Preheat until molten, then apply oxygen while tilting. To pierce plate with an oxy-fuel torch, the starting point must be preheated to a bright cherry red, molten, then cutting oxygen is applied slowly while tilting the torch slightly away from vertical. The tilt prevents molten metal from blowing back into the tip. Once the pierce is complete, the torch is straightened and normal cutting begins. Question 61. While cutting, a welder notices the flame is popping and the cut edge has excessive slag. What is the most likely cause? A. The material is too thin for oxy-fuel cutting and will cause problems with the cut. B. The cylinder pressures are too high for the tip size being used during the operation. C. The cutting speed is too fast or tip is dirty. D. The weather is too cold for cutting and affects the gas flow and flame temperature. The correct answer is C. The cutting speed is too fast or tip is dirty. Popping flame and excessive slag typically indicate cutting speed is too fast or the cutting tip needs cleaning. When speed is too fast, the oxidation reaction cannot keep up, resulting in an incomplete cut with slag. A dirty tip causes uneven oxygen flow creating unstable conditions. The welder should slow down and clean or replace the tip. Question 62. What is the primary difference between oxy-fuel cutting and oxy-fuel gouging? A. Gouging uses only oxygen without any fuel gas added to the mixture for burning. B. Cutting can only be done on thin materials due to heat requirements and capacity. C. Gouging requires significantly higher oxygen pressure than cutting operations do. D. Gouging removes metal from the surface without cutting completely through the material. The correct answer is D. Gouging removes metal from the surface without cutting completely through the material. Oxy-fuel gouging removes metal from the surface without cutting completely through the material, using a specially designed gouging tip. The tip directs the oxygen stream at a shallow angle to wash away surface metal. Gouging is used to remove weld defects, prepare joints, or remove back gouges. The technique requires a different tip and torch angle than cutting. Question 63. What is the maximum safe working pressure for acetylene gas? A. 15 psi, 103 kilopascals, exceeding this risks decomposition. B. 50 psi, 345 kilopascals, for heavy cutting applications. C. 100 psi, 690 kilopascals, matching oxygen pressure. D. No limit as long as the regulator can handle it. The correct answer is A. 15 psi, 103 kilopascals, exceeding this risks decomposition. The maximum safe working pressure for acetylene is 15 psi, 103 kilopascals. Above this pressure, acetylene becomes unstable and can decompose explosively even without an ignition source. This is why acetylene regulators are designed with a maximum delivery pressure below this threshold. All welders must be aware of this critical safety limit. Question 64. What is the correct procedure for shutting down oxy-fuel cutting equipment? A. Close both cylinder valves simultaneously and leave regulators pressurized. B. Close the fuel gas valve first, then the oxygen, and leave hoses pressurized. C. Close fuel valve, close oxygen valve, bleed lines, back out regulator adjusting screws. D. Simply turn off the torch and walk away, the equipment will depressurize naturally. The correct answer is C. Close fuel valve, close oxygen valve, bleed lines, back out regulator adjusting screws. The correct shutdown sequence is close fuel gas torch valve, close oxygen torch valve, close fuel gas cylinder valve, close oxygen cylinder valve, open torch valves to bleed pressure from hoses, close torch valves, then back out regulator adjusting screws. This procedure ensures safe depressurization and prevents damage to equipment. Question 65. What gas is most commonly used as the plasma gas for cutting mild steel? A. Compressed air for cutting. B. Pure nitrogen for cleaner cutting edges on the material surface. C. Carbon dioxide for deep penetration cuts on thick steel plates. D. Helium gas for specialized applications and non-ferrous metals. The correct answer is A. Compressed air for cutting. Compressed air is most commonly used as the plasma gas for cutting mild steel with plasma arc cutting equipment. It is economical, readily available, and produces acceptable cut quality on carbon steel. Other gases or gas mixtures may be used for specific applications, for example, nitrogen or argon-hydrogen mixtures for stainless steel or aluminum. Question 66. What must be done before striking a plasma arc? A. Turn off the shop ventilation system to reduce airflow interference with arc. B. Ensure workpiece is grounded and consumables installed. C. Apply anti-spatter compound to the workpiece cutting area before starting. D. Preheat the workpiece to 100 C before beginning the cutting operation work. The correct answer is B. Ensure workpiece is grounded and consumables installed. Before striking a plasma arc, the workpiece must be properly grounded, work lead connected, and the correct consumables, electrode, nozzle, shield, must be installed for the material type and thickness. Improper grounding prevents arc initiation or causes erratic operation. Worn or incorrect consumables produce poor cut quality and increased consumable wear. Question 67. What parameter is adjusted to change cutting speed on a plasma cutter? A. Only the gas flow rate setting on the machine. B. Only the standoff distance from the workpiece. C. The amperage setting relative to thickness. D. The color of the plasma arc during cutting. The correct answer is C. The amperage setting relative to thickness. The amperage setting is the primary parameter adjusted to change cutting speed on a plasma cutter. Higher amperage allows faster cutting of thicker material. The amperage must be matched to the material thickness. Too low results in slow cutting or failure to cut through. Too high wastes consumables and may cause excessive dross. The gas flow is typically set automatically based on amperage. Question 68. When plasma cutting, what indicates the correct cutting speed? A. The arc makes no sound during the cutting operation on the workpiece material. B. Sparks fly forward of the torch travel direction during the cutting operation. C. The workpiece does not heat up significantly during the cutting process work. D. Sparks and slag exit the bottom of the cut at a slight backward angle. The correct answer is D. Sparks and slag exit the bottom of the cut at a slight backward angle. Correct cutting speed is indicated when sparks and slag exit the bottom of the cut at a slight backward angle, about 15 to 20 degrees behind perpendicular. If sparks go straight down, the speed is too slow. If sparks trail significantly behind or the cut does not go through, the speed is too fast. Monitoring the spark pattern helps the operator maintain consistent cut quality. Question 69. A welder notices that plasma cut edges have excessive bevel, non-perpendicular. What is the most likely cause? A. The torch is not held perpendicular to the workpiece surface. B. The plasma gas is contaminated with moisture. C. The material is too thick for plasma cutting. D. The work clamp is positioned incorrectly. The correct answer is A. The torch is not held perpendicular to the workpiece surface. Excessive bevel on plasma cut edges is most commonly caused by the torch not being held perpendicular to the workpiece. The plasma arc cuts most efficiently when directed straight into the material. Even small deviations from perpendicular are amplified through the material thickness. Using a guide or machine torch helps maintain consistent perpendicularity. Question 70. What is the approximate temperature of a plasma arc? A. 1500 degrees Celsius, similar to oxyfuel flame temperature for cutting work. B. 20,000 to 30,000 degrees Celsius at core. C. 5,000 degrees Celsius, matching electric arc welding temperature during operation. D. 500 degrees Celsius, enough to melt thin materials and light gauge sheet metal. The correct answer is B. 20,000 to 30,000 degrees Celsius at core. A plasma arc reaches temperatures of approximately 20,000 to 30,000 degrees Celsius at its core. This extremely high temperature is achieved by constricting the arc through a small nozzle orifice, which concentrates the energy. This makes plasma cutting capable of cutting any electrically conductive material, including those that cannot be cut with oxyfuel. Question 71. What does SMAW stand for in welding terminology? A. Shielded metal arc welding. B. Semi-automatic metal arc welding. C. Submerged metal arc welding. D. Standard manual arc welding. The correct answer is A. Shielded metal arc welding. SMAW stands for shielded metal arc welding, commonly known as stick welding. The process uses a consumable electrode coated with flux that provides shielding gas and slag protection for the weld pool. SMAW is one of the most versatile and widely used welding processes in the industry due to its portability and ability to weld in various positions. Question 72. When setting up SMAW equipment, what is the correct polarity for welding with E7018 electrodes on mild steel? A. DC electrode negative, DCEN. B. Either polarity works equally well. C. Alternating current only. D. DC electrode positive, DCEP. The correct answer is D. DC electrode positive, DCEP. E7018 electrodes are designed to run on DC electrode positive, DCEP, also called reverse polarity. This polarity provides approximately 2/3 of the heat at the electrode and 1/3 at the workpiece, resulting in deeper penetration. While E7018 can run on AC, DCEP is the preferred polarity for optimal performance and weld quality. Question 73. What is the primary function of the flux coating on SMAW electrodes? A. To increase electrical conductivity. B. To reduce electrode consumption rate. C. To shield the weld pool from atmospheric contamination. D. To increase the melting temperature of the electrode. The correct answer is C. To shield the weld pool from atmospheric contamination. The flux coating on SMAW electrodes serves multiple purposes, but its primary function is to shield the weld pool from atmospheric contamination. When the flux burns, it creates a gaseous shield and produces slag that covers the molten weld pool, preventing oxygen and nitrogen from the air from contaminating the weld. This protection is essential for producing sound, quality welds. Question 74. What is the proper storage requirement for low hydrogen electrodes such as E7018? A. Store in a heated rod oven at specified temperature. B. Keep in original packaging until immediately before use. C. Store in a refrigerated container below 10 degrees Celsius. D. Store in a cool, dry area at room temperature. The correct answer is A. Store in a heated rod oven at specified temperature. Low hydrogen electrodes like E7018 must be stored in a heated rod oven, typically at 120 to 150 degrees Celsius, 250 to 300 degrees Fahrenheit, to prevent moisture absorption. These electrodes are extremely susceptible to moisture pickup from the atmosphere, which can lead to hydrogen-induced cracking in the weld. Once removed from the oven, they should be used within a specified time or returned to the oven for reconditioning. Question 75. When welding in the vertical up position with SMAW, what electrode angle relative to the workpiece is generally recommended? A. Perfectly perpendicular to the surface. B. 30 to 45 degrees downward from perpendicular. C. 5 to 15 degrees upward from perpendicular. D. 45 to 60 degrees upward from perpendicular. The correct answer is C. 5 to 15 degrees upward from perpendicular. When welding vertical up with SMAW, the electrode should be angled 5 to 15 degrees upward from perpendicular, slightly pointing upward. This angle helps direct the arc force into the weld pool and assists in controlling the molten metal against gravity. Too steep an angle can cause the weld pool to run ahead of the arc, while too shallow an angle reduces penetration. Question 76. What type of SMAW electrode is classified as a fast freeze electrode suitable for all-position welding? A. E7024 iron powder electrode. B. E6010 cellulosic electrode. C. E7018 low hydrogen electrode. D. E7028 iron powder electrode. The correct answer is B. E6010 cellulosic electrode. E6010 is classified as a fast freeze electrode with cellulosic flux coating. It produces a forceful, deep-penetrating arc with quickly solidifying weld metal, making it ideal for all-position welding, particularly in pipeline applications. The fast freeze characteristic allows welders to control the weld pool easily in vertical and overhead positions where gravity would otherwise cause the molten metal to drip. Question 77. A welder notices excessive porosity in SMAW welds made with E7018 electrodes. What is the most likely cause? A. Moisture contamination in the electrode coating. B. Arc length too short during the welding operation. C. Amperage setting too high for the electrode diameter. D. Travel speed too slow for the amperage being used. The correct answer is A. Moisture contamination in the electrode coating. Excessive porosity in welds made with E7018 electrodes is most commonly caused by moisture contamination in the electrode coating. E7018 is a low hydrogen electrode that readily absorbs moisture from the atmosphere. When moist electrodes are used, the water dissociates in the arc and releases hydrogen into the weld pool, which becomes trapped as porosity when the metal solidifies. Proper electrode storage in heated ovens prevents this issue. Question 78. What is the correct procedure for restarting a weld bead in SMAW after stopping? A. Strike the arc directly at the stop point and continue. B. Strike the arc well behind the stop point and weld toward it. C. Grind the stop point completely flat before restarting. D. Strike the arc ahead of the crater and backtrack to tie. The correct answer is D. Strike the arc ahead of the crater and backtrack to tie. The correct restart procedure in SMAW is to strike the arc slightly ahead of the crater, stop point, and backtrack to tie into the previous weld before continuing forward. This technique ensures complete fusion with the previous weld deposit and fills the crater. Simply restarting at the crater can result in lack of fusion or crater cracks due to the different thermal conditions. Question 79. What does the third digit 1 indicate in an E6011 electrode classification? A. All-position welding capability. B. High iron powder content. C. Low hydrogen coating type. D. High deposition rate. The correct answer is A. All-position welding capability. In the standard electrode classification system for SMAW, the third digit indicates the welding positions for which the electrode is suitable. The digit 1 indicates the electrode can be used in all positions: flat, horizontal, vertical, and overhead. Electrodes ending in 2 are suitable for flat and horizontal fillet positions only, while 4 indicates flat and horizontal positions with high iron powder content. Question 80. When welding a root pass on an open butt joint with SMAW, what technique helps ensure complete root penetration? A. Using the highest possible amperage setting for maximum penetration through joint. B. Using a slight weaving motion across the root gap. C. Maintaining a very long arc length throughout the weld pass for better visibility. D. Welding as fast as possible to minimize heat input and reduce distortion effects. The correct answer is B. Using a slight weaving motion across the root gap. Using a slight weaving or oscillation motion across the root gap helps ensure complete root penetration by allowing the arc to melt both edges of the joint and creating a keyhole effect. This technique distributes heat evenly and provides visual feedback to the welder that penetration is being achieved. The weave motion should be controlled and consistent, pausing slightly at each edge to ensure fusion. Question 81. A welder is experiencing difficulty maintaining arc stability when welding with E6010 electrodes on DC power. What adjustment would most likely improve performance? A. Switch to DC electrode negative polarity for better arc characteristics here. B. Decrease the amperage setting significantly to reduce heat input to the joint. C. Ensure power source has adequate open circuit voltage. D. Use a longer arc length to increase stability during the welding operation. The correct answer is C. Ensure power source has adequate open circuit voltage. E6010 electrodes with cellulosic coatings require power sources with adequate open circuit voltage, typically 70 to 80 volts OCV, to maintain stable arc performance. These electrodes are known to be sensitive to power source characteristics and may perform poorly on machines with lower OCV. Ensuring the power source meets the electrode's requirements is essential for proper arc stability and weld quality. Question 82. What is the recommended arc length for most SMAW applications? A. 2 to 3 times the electrode core wire diameter. B. Approximately equal to the electrode core wire diameter. C. 1 inch regardless of electrode size. D. As short as possible without stubbing. The correct answer is B. Approximately equal to the electrode core wire diameter. The recommended arc length for most SMAW applications is approximately equal to the electrode core wire diameter. For example, a 3.2 mm, 1/8 inch, electrode should be held with approximately a 3.2 mm arc length. This distance provides optimal shielding, proper heat concentration, and good bead profile. Too long an arc causes spatter and porosity, too short can cause the electrode to stick. Question 83. What is the proper technique for terminating a weld bead in SMAW to prevent crater cracks? A. Reduce travel speed and fill the crater before breaking the arc. B. Quickly snap the arc away from the workpiece surface to end the weld bead. C. Increase amperage at the end of the weld to improve penetration at crater. D. Lift the electrode straight up to break the arc at termination point end. The correct answer is A. Reduce travel speed and fill the crater before breaking the arc. To prevent crater cracks in SMAW, the welder should reduce travel speed at the end of the weld and fill the crater before breaking the arc. This can be accomplished by briefly reversing direction or pausing to deposit additional filler metal into the crater. Crater cracks occur because the center of the crater solidifies last under tensile stress. Filling the crater eliminates this stress riser. Question 84. What type of current is required for welding with E6020 electrodes? A. DC electrode positive only. B. AC or DC electrode positive. C. DC electrode negative only. D. AC current only. The correct answer is B. AC or DC electrode positive. E6020 electrodes are designed to operate on AC or DC electrode positive, DCEP. The 0 in the last digit indicates a high iron oxide coating that works well with either current type. These are flat and horizontal position electrodes with high deposition rates. The ability to use AC makes them practical for applications where DC power may not be available. Question 85. When welding thick sections with SMAW, a welder notices lack of fusion between weld passes. What is the most effective corrective action? A. Use smaller diameter electrodes for all passes on the joint. B. Decrease amperage to reduce heat input and penetration. C. Increase travel speed to prevent overheating of the base metal. D. Ensure proper interpass cleaning and direct arc into previous passes. The correct answer is D. Ensure proper interpass cleaning and direct arc into previous passes. Lack of fusion between passes in thick section welding is typically caused by inadequate cleaning between passes or improper arc direction. The corrective action involves thoroughly cleaning slag and oxide from previous passes and adjusting the welding technique to direct the arc into the fusion faces of previous beads. Proper electrode angles and slight manipulation help ensure the arc melts into previously deposited weld metal. Question 86. What is the proper sequence for multipass welding in a V-groove joint using SMAW? A. Fill passes first, then root pass, then cap. B. Cap pass first, then fill passes, then root. C. All passes should be completed in one continuous operation. D. Root pass first, then fill passes, then cap pass. The correct answer is D. Root pass first, then fill passes, then cap pass. The proper sequence for multipass welding in a V-groove joint is root pass first, followed by fill passes, and finally the cap pass. The root pass establishes full penetration at the joint root. Fill passes build up the joint thickness incrementally. The cap pass completes the joint with proper reinforcement and appearance. Each pass must be cleaned before the next is deposited. Question 87. When welding in the overhead position with SMAW, what modification to technique is recommended? A. Use lower amperage and smaller electrodes than flat. B. Use higher amperage to ensure penetration against gravity during overhead work. C. Maintain a longer arc length for better visibility during overhead welding passes. D. Use larger diameter electrodes for faster completion of the overhead weld joint. The correct answer is A. Use lower amperage and smaller electrodes than flat. Overhead welding with SMAW requires lower amperage settings and smaller diameter electrodes compared to flat position welding. The reduced heat input helps keep the weld pool manageable and prevents excessive dripping of molten metal. Smaller electrodes are easier to manipulate in the confined overhead position and produce smaller, more controllable weld pools. Tight arc length and faster travel speed also help manage the molten metal. Question 88. What safety consideration is most critical when performing SMAW in confined spaces? A. Using higher amperage for faster completion of the welding work in confined space. B. Ensuring adequate ventilation to remove fumes. C. Using larger diameter electrodes exclusively for increased deposition rate output. D. Maintaining longer arc lengths for visibility during the confined space operation. The correct answer is B. Ensuring adequate ventilation to remove fumes. Adequate ventilation is the most critical safety consideration when performing SMAW in confined spaces. Welding fumes from the electrode flux can quickly accumulate in enclosed areas, creating serious health hazards including metal fume fever and long-term respiratory damage. Forced ventilation, local exhaust, or supplied air respirators may be required depending on the space configuration and duration of welding. Question 89. What is the primary difference between GMAW and FCAW processes? A. GMAW uses solid wire while FCAW uses flux cored wire. B. GMAW requires no shielding gas while FCAW does. C. GMAW uses flux cored wire while FCAW uses solid wire. D. GMAW operates at lower temperatures than FCAW. The correct answer is A. GMAW uses solid wire while FCAW uses flux cored wire. The primary difference between GMAW, gas metal arc welding, and FCAW, flux cored arc welding, is the electrode type. GMAW uses solid wire electrodes with external shielding gas protection, while FCAW uses tubular wire electrodes with flux material in the core. The flux in FCAW provides additional shielding and can allow for self-shielded welding without external gas in some applications. Question 90. What is the correct shielding gas for GMAW welding of carbon steel in short-circuit transfer mode? A. Pure argon shielding gas. B. Pure carbon dioxide shielding gas. C. Pure helium shielding gas. D. 75% argon over 25% carbon dioxide. The correct answer is D. 75% argon over 25% carbon dioxide. A 75% argon over 25% carbon dioxide mixture, commonly called C25, is the standard shielding gas for GMAW short-circuit welding on carbon steel. This mixture provides good arc stability, minimal spatter, and proper weld penetration. Pure carbon dioxide can be used but produces more spatter, and a harsher arc. Pure argon is used for non-ferrous metals. The 75/25 mixture balances arc characteristics, penetration, and cost. Question 91. What does the designation E71T1 indicate for a flux cord welding wire? A. Flat position only wire with self-shielding capability for outdoor field work. B. Stainless steel wire for overhead welding applications in the fabrication shop. C. All-position wire with rutile slag requiring gas. D. High-deposition wire for flat and horizontal-only positions in production work. The correct answer is C. All-position wire with rutile slag requiring gas. The E71T1 designation indicates E equals electrode, 7 is equal to 70,000 psi minimum tensile strength, 1 equals all-position capability, T equals tubular, flux cord, and 1 times, after the hyphen, equals rutile slag system requiring external shielding gas. This is one of the most common FCAW wires used in structural steel fabrication due to its excellent all-position performance and smooth arc characteristics. Question 92. When setting up GMAW equipment, what determines the correct wire feed speed setting? A. The length of the gun cable assembly. B. The voltage setting and desired current. C. The type of shielding gas being used. D. The ambient temperature in the shop. The correct answer is B. The voltage setting and desired current. Wire feed speed in GMAW directly controls the welding current. Faster wire feed equals higher amperage. The correct wire feed speed is determined by the voltage setting and the desired current output for the application. These parameters must be balanced to achieve the proper metal transfer mode, short circuit, globular, or spray, and produce quality welds. Wire diameter and type also influence the specific settings used. Question 93. A welder notices excessive porosity when GMAW welding outdoors. What is the most likely cause and solution? A. Wire feed speed too high, reduce the wire feed rate setting. B. Voltage too low, increase the voltage setting on machine. C. Wind disrupting shielding gas, use wind screens or increase flow. D. Contact tip worn, replace with larger tip for proper contact. The correct answer is C. Wind disrupting shielding gas, use wind screens or increase flow. Excessive porosity when GMAW welding outdoors is most commonly caused by wind disrupting the shielding gas coverage. Even light breezes can blow away the protective gas envelope, allowing atmospheric contamination of the weld pool. Solutions include using wind screens or barriers, positioning to shield from wind, increasing gas flow rate, within limits, or switching to a self-shielded FCAW process if wind cannot be controlled. Question 94. What is the correct contact tip to work distance, contact tip to work distance, for typical GMAW applications? A. 3 to 6 mm, 1/8 to 1/4 inch. B. 10 to 19 mm, 3/8 to 3/4 inch. C. 50 to 75 mm, 2 to 3 inches. D. 25 to 35 mm, 1 to 1/3 inch. The correct answer is B. 10 to 19 mm, 3/8 to 3/4 inch. The correct contact tip to work distance, for typical GMAW applications is 10 to 19 mm, 3/8 to 3/4 inch. This distance affects electrode extension, current output, and penetration. Too short a contact tip to work distance can cause the tip to overheat and the wire to stub, too long reduces penetration and arc stability. Maintaining consistent contact tip to work distance throughout the weld is essential for uniform bead appearance and consistent weld quality. Question 95. What metal transfer mode in GMAW provides the lowest heat input and is best suited for thin materials? A. Short circuit transfer. B. Spray transfer. C. Globular transfer. D. Pulsed spray transfer. The correct answer is A. Short circuit transfer. Short circuit transfer mode provides the lowest heat input in GMAW and is best suited for thin materials and out-of-position welding. In this mode, the wire touches the weld pool and short circuits, transferring metal through surface tension. The lower heat input reduces distortion and burn-through risk on thin materials. However, it also produces lower deposition rates compared to spray transfer. Question 96. When welding vertical up with FCAW, what is the recommended technique? A. Use a straight stringer bead with fast travel speed. B. Use a slight weave or triangular oscillation pattern. C. Use downhill progression for all passes. D. Maintain the same parameters as flat position welding. The correct answer is B. Use a slight weave or triangular oscillation pattern. When welding vertical up with FCAW, a slight weave or triangular oscillation pattern is recommended. This technique helps build up the weld face, controls the molten pool against gravity, and ensures good fusion to both sides of the joint. The weave allows slight pauses at each side of the joint for proper tie-in. Parameters are typically reduced from flat position to maintain pool control. Question 97. A welder experiences frequent wire burnback when GMAW welding. What is the most likely cause? A. Gas flow rate too high causing turbulence. B. Voltage setting too high for application. C. Wire feed speed too slow relative to voltage. D. Contact tip too large for the wire diameter. The correct answer is C. Wire feed speed too slow relative to voltage. Wire burnback occurs when the wire melts back to the contact tip, and it is most commonly caused by wire feed speed being too slow relative to the voltage setting. The high voltage creates a long arc that melts the wire faster than it is being fed. To correct this, either increase wire feed speed or decrease voltage to balance the parameters. A worn or damaged drive roll can also cause inconsistent feeding leading to burnback. Question 98. What is the primary advantage of using self-shielded FCAW wire over gas-shielded FCAW? A. Produces cleaner welds with less spatter and improved bead appearance quality. B. Can be used in windy outdoor conditions without gas. C. Better suited for thin material applications and light gauge sheet metal work. D. Lower cost per kilogram of deposited weld metal during production operations. The correct answer is B. Can be used in windy outdoor conditions without gas. The primary advantage of self-shielded FCAW is that it can be used in windy outdoor conditions without external shielding gas. The flux core contains materials that generate shielding gas and slag protection when heated, eliminating the need for external gas that can be blown away by wind. This makes self-shielded FCAW ideal for outdoor construction, field welding, and other applications where gas shielding is impractical. Question 99. What is the correct drive roll type for feeding flux cord welding wire? A. Knurled or serrated drive rolls. B. Smooth V-groove drive rolls. C. U-groove drive rolls. D. Flat drive rolls. The correct answer is A. Knurled or serrated drive rolls. Knurled or serrated drive rolls are required for feeding flux cord welding wire. The softer tubular construction of flux cord wire requires the additional grip provided by the knurled surface to feed reliably. Smooth V-groove rolls used for solid wire would slip on flux-cored wire and cause inconsistent feeding. U-groove rolls are used for aluminum wire, which is even softer. Question 100. What shielding gas is typically used for spray transfer GMAW on aluminum? A. 75% argon over 25% carbon dioxide mixture. B. Pure argon or argon over helium mixture. C. Pure carbon dioxide. D. Argon over oxygen mixture. The correct answer is B. Pure argon or argon over helium mixture. Pure argon or argon over helium mixtures are used for GMAW welding of aluminum. Argon provides a stable arc and good cleaning action on aluminum oxide. Helium additions, up to 25 to 50%, can be added to increase heat input for thicker sections. Carbon dioxide or carbon dioxide mixtures cannot be used on aluminum as they would cause oxidation and contamination of the weld. Question 101. When GMAW welding stainless steel, what type of shielding gas mixture is recommended? A. 75% argon over 25% carbon dioxide gas mixture. B. Pure carbon dioxide shielding gas only. C. 98% argon over 2% oxygen or trimix with helium. D. Pure nitrogen as the shielding gas only. The correct answer is C. 98% argon over 2% oxygen or trimix with helium. For GMAW welding of stainless steel, a shielding gas of 98% argon over 2% oxygen or a trimix containing helium is recommended. The small oxygen addition stabilizes the arc and improves wetting without excessive oxidation. Trimix gases, argon over helium/carbon dioxide, can improve penetration and arc characteristics. Higher carbon dioxide percentages used for carbon steel would cause excessive oxidation and carbon pickup in stainless steel. Question 102. A welder notices bird nesting, tangled wire, at the drive rolls during GMAW. What is the most likely cause? A. Excessive drive roll pressure or restriction in liner. B. Voltage setting too high for the wire diameter used. C. Wire feed speed too fast for the amperage setting. D. Gas flow rate too high causing turbulence at the nozzle. The correct answer is A. Excessive drive roll pressure or restriction in liner. Bird nesting occurs when wire tangles at the drive rolls, and it is most commonly caused by excessive drive roll pressure combined with a restriction in the gun liner or tip. The drive rolls push wire faster than it can exit, causing it to buckle and tangle. A kinked liner, wrong liner size, worn contact tip, or blocked tip can all cause this restriction. Proper drive roll tension and regular liner over tip maintenance prevent bird nesting. Question 103. What does MCAW stand for in welding terminology? A. Metal cord arc welding. B. Manual carbon arc welding. C. Mixed current arc welding. D. Microcurrent arc welding. The correct answer is A. Metal cord arc welding. MCAW stands for metal cord arc welding, which uses tubular wire electrodes with metal powder in the core rather than flux. Metal cord wires combine the high deposition rates of flux cord wires with the low spatter characteristics of solid wires. They produce minimal slag and are used in applications requiring high productivity and good weld appearance, particularly in robotic and automated welding systems. Question 104. What is the proper procedure for changing wire spools on a G.M.A.W/F.C.A.W system? A. Cut wire and pull remaining wire backward through the liner assembly carefully. B. Release tension, cut wire, and feed new wire through. C. Leave old wire in liner and weld new wire to it for a continuous connection. D. Force new wire through without removing old wire from the system components. The correct answer is B. Release tension, cut wire, and feed new wire through. The proper procedure for changing wire spools involves releasing drive roll tension, cutting the wire near the drive rolls, removing the old spool, installing the new spool, and feeding the new wire through the cable assembly and contact tip. The liner should be kept clear and free of debris. Never weld wires together or force wire through the system, as this can damage the liner and cause feeding problems. Question 105. What is the typical flow rate range for shielding gas in GMAW welding? A. 40 to 60 liters per minute, 85 to 125 cubic feet per hour. B. 5 to 10 liters per minute, 10 to 20 cubic feet per hour. C. 15 to 25 liters per minute, 30 to 50 cubic feet per hour. D. 1 to 3 liters per minute, 2 to 6 cubic feet per hour. The correct answer is C. 15 to 25 liters per minute, 30 to 50 cubic feet per hour. The typical shielding gas flow rate for GMAW welding is 15 to 25 liters per minute, 30 to 50 cubic feet per hour, cubic feet per hour. This range provides adequate shielding without excessive turbulence that can draw in atmospheric contamination. Flow rate may be adjusted based on joint configuration, gun angle, nozzle size, and environmental conditions. Higher flow rates may be needed for larger nozzles or windy conditions. Question 106. What maintenance task should be performed regularly on the GMAW gun nozzle? A. Replace the nozzle after every welding session. B. Tighten the nozzle with pliers after each weld. C. Apply grease to the inside of the nozzle. D. Clean spatter buildup and apply anti-spatter compound. The correct answer is D. Clean spatter buildup and apply anti-spatter compound. The GMAW gun nozzle should be regularly cleaned of spatter buildup and treated with anti-spatter compound. Spatter accumulation restricts gas flow and can fall into the weld, causing defects. Anti-spatter compound, gel or spray, helps prevent spatter from adhering to the nozzle. The contact tip should also be inspected and replaced when worn or damaged. Regular maintenance ensures consistent gas coverage and wire feeding. Question 107. When welding galvanized steel with GMAW or FCAW, what special precaution is most important? A. Use pure carbon dioxide shielding gas exclusively for the galvanized steel welding work. B. Weld at maximum amperage for best results and deeper penetration into base metal. C. Ensure adequate ventilation for zinc fumes. D. Skip post-weld cleaning to preserve the coating and prevent corrosion damage. The correct answer is C. Ensure adequate ventilation for zinc fumes. When welding galvanized steel, adequate ventilation is critically important because the zinc coating vaporizes and creates toxic zinc oxide fumes. Exposure to these fumes can cause metal fume fever with flu-like symptoms. Local exhaust ventilation, positioning to avoid fume inhalation, and respiratory protection are essential. The galvanized coating also affects weld quality, often requiring reduced travel speed and adjustments to technique. Question 108. What is the correct gun angle for GMAW welding a fillet weld in the horizontal position? A. 90 degrees to the workpiece, perpendicular. B. 45 degrees to the joint, bisecting the angle. C. 30 degrees from vertical toward the bottom plate. D. 60 degrees from horizontal toward the top plate. The correct answer is B. 45 degrees to the joint, bisecting the angle. For GMAW fillet welding in the horizontal position, the gun should be angled at approximately 45 degrees to the joint, bisecting the angle between the two plates. This directs the arc and filler metal equally into both members of the joint. The travel angle, push or drag, is typically 5 to 15 degrees in the direction of travel. Proper gun angle ensures equal leg sizes and good fusion to both plates. Question 109. What is the purpose of the inductance control on a GMAW power source? A. To increase maximum amperage output of the power source for thicker materials. B. To adjust shielding gas flow rate at the nozzle outlet for better coverage. C. To control rate of current rise during short circuit. D. To regulate wire feed speed and deposition rate output during production work. The correct answer is C. To control rate of current rise during short circuit. Inductance control on a GMAW power source adjusts the rate of current rise during short circuit transfer. Higher inductance creates a slower current rise, resulting in a softer arc with less spatter but potentially less penetration. Lower inductance provides faster current rise, creating a crisper arc with more penetration but increased spatter. This control allows welders to fine-tune arc characteristics for specific applications. Question 110. What does GTAW stand for in welding terminology? A. Gas tungsten arc welding. B. General thermal arc welding. C. Guided torch arc welding. D. Gas tungsten automatic welding. The correct answer is A. Gas tungsten arc welding. GTAW stands for gas tungsten arc welding, also commonly known as TIG, tungsten inert gas, welding. This process uses a non-consumable tungsten electrode to produce the arc, with separate filler metal added manually when needed. An inert shielding gas, typically argon or argon over helium mixture, protects the weld zone. GTAW produces the highest quality welds and is used for critical applications. Question 111. What type of current and polarity is used for GTAW welding of steel and stainless steel? A. DC electrode negative, DCEN. B. DC electrode positive, DCEP. C. Alternating current, AC. D. Variable polarity. The correct answer is A. DC electrode negative, DCEN. DC electrode negative, DCEN, also called straight polarity, is used for GTAW welding of steel and stainless steel. This polarity concentrates approximately 70% of the heat at the workpiece and 30% at the electrode, providing good penetration while keeping the tungsten electrode cool. DCEP would rapidly overheat and destroy the electrode. AC is used for aluminum to provide oxide cleaning action. Question 112. Why is alternating current, AC, used for GTAW welding of aluminum? A. AC provides deeper penetration than DC for aluminum welding. B. AC prevents the tungsten electrode from melting during use. C. Aluminum requires the higher frequency of AC current flow. D. The electrode positive portion of cycle provides oxide cleaning. The correct answer is D. The electrode positive portion of cycle provides oxide cleaning. AC is used for GTAW welding of aluminum because the electrode positive, EP, portion of the cycle provides a cleaning action that removes the aluminum oxide layer. Aluminum oxide has a much higher melting point than aluminum and must be removed for proper fusion. During the EP half cycle, electrons flow from the workpiece to the electrode, breaking up the oxide layer. The electrode negative half cycle provides the majority of welding heat. Question 113. What is the correct electrode tip preparation for GTAW welding with DC on steel? A. Flat blunt tip for wide arc spread. B. Rounded ball tip for AC welding. C. Ground to a point with longitudinal marks. D. Chisel-shaped tip for narrow joints. The correct answer is C. Ground to a point with longitudinal marks. For DC GTAW welding on steel, the tungsten electrode should be ground to a point with longitudinal grinding marks, parallel to the electrode axis. The pointed tip concentrates the arc for precise control, and longitudinal grinding produces uniform arc characteristics. The included angle of the point, typically 30 to 60 degrees, affects arc shape and penetration. A dedicated grinding wheel should be used to prevent contamination. Question 114. A GTAW welder notices tungsten inclusions in completed welds. What is the most likely cause? A. Shielding gas flow rate too high causing turbulence issues. B. Filler rod diameter too large for the joint thickness. C. Welding current too low for proper fusion and penetration. D. Tungsten electrode touching the weld pool during welding. The correct answer is D. Tungsten electrode touching the weld pool during welding. Tungsten inclusions in GTAW welds are caused by the tungsten electrode touching the weld pool or filler rod, causing small particles of tungsten to break off and become embedded in the weld. This commonly occurs when dipping the electrode into the pool during arc starts, or when the electrode gets too close during welding. If contamination occurs, the affected portion of the electrode should be removed and the tip reground. Question 115. What is the purpose of post-flow in GTAW welding? A. To increase penetration at the end of the weld bead for complete fusion joint. B. To reduce amperage gradually at the weld termination point for proper finish. C. To protect tungsten and weld pool while cooling. D. To preheat the filler rod before the next weld pass to improve deposit quality. The correct answer is C. To protect tungsten and weld pool while cooling. Post-flow continues the shielding gas flow after the arc is extinguished to protect the hot tungsten electrode and the cooling weld pool from atmospheric contamination. Without post-flow, the hot tungsten oxidizes rapidly and the weld crater can develop porosity. Typical post-flow times are 5 to 15 seconds depending on amperage used. The post-flow time should be approximately 1 second per 10 amps of welding current. Question 116. When GTAW welding pipe in the 6G position, what technique is used for the root pass? A. High amperage with fast travel speed for maximum deposition rate and penetration. B. Walking the cup technique with controlled keyhole. C. Maximum torch angle for deep penetration into the root of the pipe joint weld. D. Pulsing between high and 0 amperage for heat control during root pass work. The correct answer is B. Walking the cup technique with controlled keyhole. The walking the cup technique combined with controlled keyhole formation is used for GTAW root passes on pipe in the 6G, 45-degree fixed, position. Walking the cup involves rocking the gas cup from side to side on the pipe surface while progressing around the joint. The welder maintains a small keyhole at the leading edge of the weld pool to ensure complete root penetration. This technique provides excellent control and consistent results. Question 117. What type of tungsten electrode is commonly used for AC welding of aluminum? A. Pure tungsten green for all AC welding. B. Thoriated tungsten red for high amperage. C. Cariated or lanthanate tungsten gray over blue. D. Any tungsten type works equally well here. The correct answer is C. Cariated or lanthanate tungsten gray over blue. Cariated, gray, or lanthanate, blue, tungsten electrodes are commonly recommended for AC welding of aluminum. These rare earth oxide additions provide excellent arc starting, good arc stability on AC, and longer electrode life compared to pure tungsten. Pure tungsten forms a ball tip on AC but has less desirable arc characteristics. Thoriated tungsten is being phased out due to radioactivity concerns and is better suited for DC welding. Question 118. What is the proper filler rod angle when adding filler metal in GTAW welding? A. 90 degrees perpendicular to the weld axis. B. Parallel to the tungsten electrode. C. 30 to 45 degrees from vertical, pointing away from direction of travel. D. 15 to 30 degrees from horizontal, fed into the leading edge of the pool. The correct answer is D. 15 to 30 degrees from horizontal, fed into the leading edge of the pool. In GTAW welding, the filler rod should be held at a low angle of 15 to 30 degrees from horizontal and fed into the leading edge of the weld pool. The rod is kept close to the workpiece and dipped into the pool with a rhythmic motion coordinated with torch movement. The low angle helps keep the rod end in the gas shielding envelope and allows smooth addition of filler without disturbing the arc. Question 119. What does SAW stand for in welding terminology? A. Semi-automatic welding. B. Submerged arc welding. C. Shielded arc welding. D. Spray arc welding. The correct answer is B. Submerged arc welding. SAW stands for submerged arc welding. In this process, the arc is completely submerged beneath a layer of granular fusible flux, which protects the weld zone from atmospheric contamination. The flux also provides alloying elements to the weld and forms a slag layer that protects the cooling weld metal. SAW is used for high production welding of thick sections in the flat and horizontal positions. Question 120. What welding positions are typically used for SAW welding? A. Flat and horizontal positions only. B. All positions including vertical and overhead. C. Vertical up position only. D. Overhead position preferred for deep penetration. The correct answer is A. Flat and horizontal positions only. SAW welding is typically limited to flat and horizontal positions only. The granular flux relies on gravity to remain in place over the weld zone, making vertical and overhead positions impractical. Special equipment can be used for circumferential welding of pipe or vessels in the horizontal rolled position. The process excels in flat position welding where high deposition rates and deep penetration can be fully utilized. Question 121. What is a primary advantage of the SAW process compared to other arc welding processes? A. Lower equipment cost than other processes. B. Ability to weld thin materials effectively. C. High deposition rate and deep penetration. D. No flux or slag handling is required. The correct answer is C. High deposition rate and deep penetration. The primary advantages of SAW are its high deposition rate and deep penetration capability. The submerged arc allows high currents, up to 2000 plus amps, without the arc radiation and spatter associated with exposed arc processes. This results in high productivity for welding thick sections. Single-pass welds up to 16 mm thick are possible. The deep flux blanket also provides excellent mechanical properties and smooth weld appearance. Question 122. What happens to unfused flux in SAW welding after welding is complete? A. It must be disposed of and cannot be reused. B. It burns off completely during welding. C. It is incorporated into the weld metal. D. It is recovered for reuse in subsequent welds. The correct answer is D. It is recovered for reuse in subsequent welds. Unfused flux in SAW welding is recovered for reuse. The flux recovery system vacuums up unfused flux from behind the welding head and returns it to the flux hopper. Only the flux directly involved in the arc melts and becomes slag. The surrounding granular flux remains unfused and can be recycled. Proper flux recovery and handling practices are important for maintaining consistent weld quality and reducing material costs. Question 123. A SAW operator notices poor bead appearance with undercut on one side. What is the most likely cause? A. Flux layer too thick over the weld. B. Travel speed too slow for settings. C. Electrode misaligned with joint centerline. D. Amperage setting too low for the job. The correct answer is C. Electrode misaligned with joint centerline. Undercut on one side of a SAW weld typically indicates electrode misalignment with the joint centerline. Because the arc is submerged and not visible, the operator cannot see electrode position during welding. Even small misalignments cause the arc to favor one side, creating undercut on the opposite side. Proper joint tracking equipment and alignment procedures are essential for consistent SAW weld quality. Question 124. What is the recommended flux depth for most SAW applications? A. Just enough to barely cover the arc, 5 to 10 mm, for visibility during the operation. B. 25 to 40 mm, 1 to 1.5 inches, completely covering arc. C. As deep as possible for maximum protection of the weld pool from contamination. D. Flush with the top of the joint preparation surface level for proper coverage. The correct answer is B. 25 to 40 mm, 1 to 1.5 inches, completely covering arc. The recommended flux depth for SAW is typically 25 to 40 mm, 1 to 1.5 inches, enough to completely submerge the arc. Too shallow a flux layer allows arc flash and atmospheric contamination. Too deep a flux layer can trap gases, cause rough weld surfaces, and waste flux. The flux pile should be uniform along the joint and extend equally on both sides of the weld center line. Question 125. What type of flux system is used in SAW to add alloying elements to the weld metal? A. Neutral flux system for the weld. B. Basic flux system for the weld. C. Active or alloy flux system. D. Acidic flux system for the weld. The correct answer is C. Active or alloy flux system. Active or alloy flux systems in SAW contain deoxidizers and alloying elements that transfer to the weld metal during welding. These fluxes can add manganese, silicon, and other elements to improve weld metal properties. Neutral fluxes do not add or remove significant alloying elements, while basic fluxes provide improved impact properties. The flux selection must be matched to the wire and base metal composition for the desired weld properties. Thanks for watching Factorial. If you found this helpful, please subscribe for more Red Seal exam prep. Visit questionbankhub.com for practice exams and study materials. Good luck on your certification Factorial.